Okay, before you start this assignment, which really takes into account all the things that we've done, I wanted to talk to you about these computer printouts because there are some things on the computer printout we will use and some of the things we will not use. So, with this computer printout that we have here on assignment or day 4 assignment, we see that the variables we're going to be using are female rate and male rate, okay, as it lists there. So everything on the top, the first row is for females, second row is for males, and then it's a continuation down here. The first row is females and the second row is males. Now, this N, of course, we know N is the number of pieces of data. So we have 36 females and 36 males. We don't really need that in this information for now. And so here we have the mean. So the mean has been calculated, and there's the printout for the females and males, median as well. Now, this is called trimmed mean. We do not need that because trimmed mean uh, happens whenever they take off the highest piece of data and the lowest piece of data in case those were outliers, and then takes care of that way, and then recalculates. Uh, that is actually a distractor in AP on the AP statistics exam. We will never use the trimmed mean. They will have answer choices that utilized the trimmed mean, and those would then be the wrong answers. So you do not want it to be having had used the trimmed mean. Here's your standard deviation for the females and the males. So see, here's your mean plus two standard deviations would give you the upper fence. And for the lower fence, you could do the mean minus two of these standard deviations to get the lower fence. Okay, if you were using the standard deviation fence rule. Then we see here, oh, this is standard error of the mean. We will not use that until the very last unit this year. On the next row, you see we are given the minimum and the maximum values in the data set. And then Q1, which is your quartile 1 and your Q3. So you will use those. Then I came over here and I made this where I then calculated what the IQR is, because I know if I'm going to use the IQR fence rule, then see for my upper fence, I've got the Q3 plus 1.5 IQRs and the lower fence Q1 minus. So you know this information from our lesson yesterday about the two different types of fence rules and outlier borders. So you know then any data above the upper fences or any data below the lower fences are outliers. Okay, so now we are then asked on this page to compute the fences for both the males and the females, but at first it just takes you through the females. And it wants you to do those with the two different rules. So you're going to get to practice the IQR rule. So you'll do the formula for the female data using the IQR outlier fence rules, and then you'll do the female fences with standard deviation rule. And once you do that, then you will be asked about, are there outliers? And if so, how many? So I'm going to give you a moment to do that computing and practice that computing on your own. And so go ahead and pause the video here so that you can try to do some of that computing on your own and check as you do those. So pause and make your fences. All right. So I have completed that already. And I have gotten these values here. So for my IQR rule, my upper for the females was 26.375 and 3.375 for the lower. And it looked like this. Okay, I actually don't know if this box plot is representative. The dots are here because I'm not exactly sure where the whisker goes to. This is just kind of giving you an idea of what's going on here with a fence at a lower fence at 3.75 and a lower fence or an upper fence at 26.375. Okay. So now the question is, um, what, if any, outliers do we have? So, in order to do that, you need to look at this minimum and maximum piece of data so that you can see where we know the lowest and the highest piece of data fell. So, I'm going to look at that. The max for the females was 21. Okay, so I don't know exactly where this is, but I do know that that is within the fence. So therefore my whisker can go all the way out there, and I do not, it is not an outlier. I do not have an upper outlier because it is not past the upper fence. All right. Then look at the minimum for the females. That is 2. So let's see where that is. My fence is at 3.75. So that means that minimum is down here lower than that 3.75. So I know that I have that one for sure that is an outlier. But here's the thing. Could there be more? And that answer is yes, because I do not know how many pieces of data. Maybe there's another one, another female that got 2. Maybe there's a female that got the number 3 or 3.1. I do not know how many outliers there are because I do not know all of those 36 pieces of data. I just know that the minimum, I just know there's at least one lower outlier. So that's what I can confirm here is that there is at least one lower outlier and there's no upper outliers. Okay, so no upper outliers. All right, now let's look at the results from our standard deviation rule. So these are how I did that: mean plus 2 standard deviations and mean minus 2 standard deviations. I got 22.191 and 6.63 something or other. And here's what that looks like. Okay. So we've got that our fence was here at 21, and then 2 standard deviations below was at 6.643. So once again, 21 is within the fence. So therefore, I do not have an upper outlier because it did not pass the upper fence. But now look here again. The minimum was down here at 2. So if 6.643 is that fence, then the minimum is 2. And yes, there could be others, but I do not know what others there are. So once again, same decision or same conclusion. I have at least one lower outlier, and then I have no upper outlier. So in summary, I know that I fall into this category, at least one outlier overall. No matter which rule I used, it's at least one outlier for the females. Now look at the other options that you can have. If there were no lower or no upper, then you would have the no outliers. Here is at least one where it was either the upper or the lower, and then at least two. At least two would happen only if you know you have at least one lower and at least one upper, then you know for a fact that at the very least there is 2. Now, there could be more, but there's at least 2. So, those are your 3 options for how many outliers you have. All right. So, there is done with that understanding of the outliers and the number of those outliers based on the fences and the computer printout. So, next, we did not get a chance to really talk about this very well in class yesterday, if any. I don't even think we did. So, I wanted to talk to you about the relationship between the value of the mean, the median, and the mode, and the shapes effect on that. So we're going to take a look here at we're going to look at the shapes that are symmetric, that are skewed left, and that are skewed right. And so let's take a look at these down here. So for the symmetrical ones, the mean, median, and mode are about equal. Okay? Mean, median, and mode are about, so I kind of put squiggly equals because they're about the same values. Now, you have to write these words in alphabetical order. Mean, median, mode. And I did it again. Mean, median, mode. Mean, median, and mode. Okay, so the next, let's talk skewed left. So skewed left looks like your left foot. So of these pictures down here, which one is skewed left? And that would be this one here. This is skewed left. Okay. Draw an inequality in the shape of that skew. And that looks like this. There it is. So now that is the inequality that goes here. So that tells me when this shape is skewed left, that the mean's value is less than the median, and the median's value is less than the mode. All right. Same thing with the skewed right. So here is your right foot, skewed right. So draw an inequality over that skewed right, and that is, here it is. There's the inequality in the shape of that skewed right distribution. So if a distribution is skewed right, then the mean is greater than the median, which is greater than the mode. So let me quiz you. Well, I'll go ahead and leave these pictures up here. So what if I tell you the mean is 3 and the median is 4? What is the shape of the distribution? Well, the mean is less than the median. So, ta-da-ta-da, that is skewed left. That's how that works. What if I told you the mean is 4.6 and the median is 4.603? Okay, because in real data, it's not going to be the same, exactly the same. So those are relatively close. Could even be 4.5, whatever. Relatively close, so it's approximately symmetric. All right, you get the idea. So now you are going to complete the rest of this assignment for the males, and then you'll be working on the assignment here where we're doing, let's see here, if I can get this to move forward. Um, the a few problems here, and then these ones are histograms where you are trying to find the piece of data that contains the Q1, or where the Q1 is located and where the Q3 is located, and so on. So you'll get to work on that. And once you're finished there, then you'll have some frequency tables. This AP question here, it's kind of got some pretty intense thought processes going on right now. So I'm going to, at this point today, because we are quizzing tomorrow, say that this page 26 AP question is optional at this point. Okay. And then you'll go and do your warm up and I will turn the key to this assignment on at 4 o'clock, since you will then be having a quiz on that tomorrow. All right. So good luck with your assignment, and you get to work on assignment 4 and the warm up day 4.